Hello students, welcome to this lecture on probability. So in this lecture we will discuss exercise 14.1. Okay. So in first question here we have to complete the following statements. So in first question here we have given some statements and we need to fill the blank. So in first one here we have probability of an event E plus probability of the event not E is equal to what? So student, we have studied in our previous lecture, there we have studied probability of plus probability of not E equal to 1. Okay, so probability of E plus probability of the event not E is equal to 1. In second question, we have the probability of an event that cannot happen is what, and such an event is called what. So we have studied in our theory class, there we have studied the probability of an event that cannot happen is 0. Okay, and such an event is called impossible event. In third one, we have the probability of an event that is contained that is certain to happen. Okay, is dash. Such an event is called dash. So we know the probability of an event that is certain to happen is 1. Okay, and such an event is called certain event or sure event. And fourth one, here we have the sum of the probabilities of all elementary events of an experiment is dash. So the sum of the probabilities of elementary events of an experiment is 1. Okay, that we have studied in our previous lecture. So you can visit our website and there you will see the previous lectures on this topic. Okay, so there you will see the theory about this question. Okay, so there we have studied about this in details. So in fifth one, we have the probability of an event is greater than or equal to and less than or equal to dash. So we know probability of an event is always greater than or equal to 0 and less than or equal to 1. Okay, so for first one the answer is 1, and for second one answer are 0 and impossible event, and in third one the answer are 1 and sure event or certain event. Okay, and for fourth one answer is 1, and the fifth one answer are 0 and 1. Okay students, so now let us move to next problem. So in next question here we have which of the following experiment have equally likely outcomes. Okay, and explain. So what is actually equally likely outcome that we have studied in our previous lecture. Okay, so in this question we need to explain we need to find the experiment which have equally likely outcomes. Okay, and also we have to explain why this equally likely outcome or not equally likely outcomes. Okay, so first of one, here we have the a driver attempts to start a car. The car starts or does not start. Okay, so this experiment have the experiment equally likely outcomes. Okay, so let's see. In first one here, it is not an equally likely event. Okay, as it depends on various factors such as whether the car will start or not. Okay, and factors for both the conditions, both car will start or not, that conditions are not the same. Okay, so that is why this event, this experiment is not does not have the experiments this experiment, a driver attempts to start a car, the car starts or does not start. This experiment does not have equally likely outcomes. Okay, and now let us see next one. So in next one here we have a player attempts to shoot a basketball. She or he shoots or misses the shot. Okay, so this is the experiment, and we have to justify whether the experiment have equally likely outcomes. Okay, so let us check. So it is not an equally likely event, as it depends on the player's ability. Okay, so it depends on player ability, and there is no information given about that. Okay, so this is why this this experiment this experiments does not have equally likely outcomes. Okay, and now let us see third one. So in third one, here we have a trial is made to answer a true false question. Okay, so the answer is right or wrong. So this experiment, just we have to justify whether the experiment have equally likely outcomes. Okay, so let us see. In third one, it is an equally likely event. Why? Because every possible outcomes have same possibility. Okay, that is why this experiments a trial is made to answer a true false question. The answer is right and wrong. These experiments have equally likely outcomes. Okay, and then let us see fourth one. So in fourth one, here we have a baby is born. It is a baby, it is a boy or a girl. Okay, so a baby is born, and it is a boy or a girl. This is experiment. Okay, so this experiment basically is an equally likely event. Okay, so it does not depends on one one various factors. Okay, it mainly there two possibility, either the baby is boy or a girl. Okay, and when the possibility to occur, the possibility to happen a boy is same as the possibility to born a girl. Okay, so they are same. That is why this experiment have equally likely outcomes. And now let us move to next problem. So in next problem, here we have, why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of a football game? Okay, this is the question. So now let us answer this question. So let us see answer. So when we toss a coin, the possible outcomes are only two, head or tail, which are equally likely outcomes. Okay, so therefore the result of an individual toss is completely unpredictable. Okay, so the result of an individual toss is completely unpredictable. And now let us move to next problem. So in next problem, here we have given some probability. Okay, probability of an event. Okay, and among this probability, which of the following cannot be the probability of an event? Okay, so in option A, here we have 2 by 3. In option B, here we have minus 1.5. And in option C, we have 1 by 5. And in option D, we have 0.7. Okay, so among these four options, which cannot be the probability of an event? So here we know that probability of an event E is always greater than or equal to 0. Okay, and it is always less than or equal to 1. Also, it is always less than or equal to 1. So this implies that the probability of an event cannot be negative or greater than 1. Okay, therefore out of these alternatives here, minus 1.5, that is in option number B. Okay, so minus 1.5, this cannot be a probability of an event. Hence option B is here correct answer. And now let us move to next problem. So in next problem, here we have, if probability of E is equal to 0.05, then what is the probability of not E? Okay, so here we have to find what is the probability of not E? So let us find. So here we know that this formula, probability of not E, that is actually probability of E bar. Okay, so probability of E bar, this is equal to 1 minus probability of E. Okay, and here we have given probability of E is equal to 0.05. So probability of E bar, this is equal to 1 minus 0.05, and this is equal to 0.95. Okay, so probability of E bar is equal to 0.95. So therefore the probability of not E is 0.95. Okay, so now let us move to next problem. So in next problem, here we have a bag contains lemon flavor candies only. Okay, and Malini takes out one candy without looking into the bag. What is the probability that she takes out an orange flavor candy and second a lemon flavor candy? Okay, so here we have to find what is the probability that she takes out an orange flavor candy, number one, and number two, what is the probability that she takes out a lemon flavor candy? Okay, so let us see answer. So here the bag contains lemon flavor candies only. Okay, there is no orange flavor candies. Okay, so the bag only contains lemon flavor candies. So it does not contain any orange flavor candies, and this implies that every time she will take out only lemon flavor candies. Therefore, even that Malini will take out an orange flavor candy is an impossible event. It cannot be happen. Okay, since the bag contains lemon flavored candies only, it does not contain any orange flavored candies. Okay, so therefore the event that Malini will take out an orange flavored candy is an impossible event. Okay, and we know when an event is impossible event, that case probability of that event is equal to 0. Okay, hence probability of an orange flavored candy is equal to 0. Probability of an orange flavored candy is equal to 0. And now go to second. So in second, we have to find what is the probability that she takes out an lemon flavored candy. Okay, so bag contains lemon flavor candies only. Okay, as the bag has lemon flavor candies, Malini will take out only lemon flavor candies. Okay, therefore even that Malini will take out a lemon flavor candy is your event. So probability of a lemon flavor candy is equal to 1. Okay, so now let us move to next problem. So in next problem, here we have, it is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. Now, what is the probability that the 2 students have the same birthday? Okay, so here we need to find what is the probability that 2 students have the same birthday, and here we have given the probability of 2 students not having the same birthday is 0.992. Okay, so let us solve this problem. So let us see answer. So here probability that 2 students are not having same birthday P of either. So P of either, this is equal to 0.992, and probability that 2 students are having same birthday, probability of E is equal to 1 minus probability of bar. And here we have given the probability of 2 students are having same are not having same birthday is equal to 0.992. Okay, so probability that 2 students are having same birthday, P of E, this is equal to 1 minus 0.992. Okay, and this is equal to 0.008. Okay, so probability that 2 students are having same birthday is equal to 0.008. And now let us move to next problem. So in next problem, here we have a bag contains 3 red balls and 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn is red and not red? Okay, so here we have given a bag that contains 3 red balls and 5 black balls. Okay, so here the total balls is equal to 8. So now let us see how to solve this problem. Here total number of balls in the bag, this is equal to 8. Okay, and probability of getting a red ball, this is equal to number of favorable outcomes of the event of getting a red ball divided by number of total possible outcomes. Okay, here the number of red balls is equal to 3, so this is equal to 3 by 8, since the number of total possible outcome is 8. Okay, and probability of not getting red ball, this is equal to actually 1 minus probability of getting a red ball. Okay, so this is equal to 1 minus 3 by 8, and this is equal to 8 minus 3 by 8, that is 5 by 8. Okay, so probability of not getting red ball, this is equal to 5 by 8. And now let us move let us move to next problem. So in next problem, here we have a box that contains 5 red marbles, 8 white marbles and 4 green marbles. One marble is taken out of the box at random. What is the probability that the marble taken out will be red, white and not green? Okay, so let us solve this problem. So let us see answer. So total number of marbles is equal to 5 plus 8 plus 4, that is equal to 17. Okay, so total number of marbles, this is equal to 17. And now we need to find the probability of getting a red marble. Okay, so number of red marbles is equal to here 5 and total number of marbles is equal to 17. Okay, so probability of getting a red marble, this is equal to number of favorable outcomes divided by number of total possible outcomes. Okay, and this is equal to 5 by 17. Okay, so probability of getting a red marble, this is equal to 5 by 17. And then number of white marbles is equal to 8. Then probability of getting a white marble, this is equal to number of favorable outcomes divided by number of total possible outcomes. Okay, so here the number of favorable outcomes is 8 and number of total possible outcome is 17. Okay, so probability of getting a white marble, this is equal to 8 by 17. Okay, so the probability of getting a white marble is equal to 8 by 17. And let us find probability of getting a green marble. Okay, so here number of green marbles is equal to 4. So probability of getting a green marble, this is equal to number of favorable outcomes divided by number of total possible outcomes. Okay, so this is equal to 4 by 17. Okay, 4 by 17. Now probability of not getting a green marble is equal to 1 minus probability of getting a green marble. Okay, and this is equal to 1 minus 4 by 17 and this is equal to 13 by 17. Okay, and now let us move to next problem. So in next problem, here we have a piggy bank contains 150 p coins. Okay, and 50 p coins, 50 rupees 1 coins, 20 rupees 2 coins and 10 rupees 5 coins. Okay, 10 rupees 5 coins. If it's equally likely that one of the coins will fall out when the bank is turned upside down. Okay, what is the probability that the coin will be a 50 paisa coin? Okay, and will not be a rupees 5 coin, will not be a rupees 5 coin. So let us solve this problem. So the total number of coins in a piggy bank is equal to 100 plus 50 plus 20 plus 10, that is equal to 180. Okay, so total number of coins in a piggy bank is equal to 180. And now number of 50 paisa coins, this is equal to 100. So probability of getting a 50 paisa coin is equal to number of number of favorable outcomes divided by number of total possible outcomes. Okay, and this is equal to 100 by 180, and this is equal to 5 by 9. Okay, so probability of getting a 50p coin is equal to 5 by 9. And now number of rupees 5 coins is equal to 10. So probability of getting a rupees 5 coin is equal to number of favorable outcomes divided by number of total possible outcomes. Okay, and this is equal to 10 by 180, and this is equal to 1 by 18. Okay, so probability of getting a rupees 5 coin is equal to 1 by 18, and probability of not getting a rupees 5 coin is equal to 1 minus 1 by 18, that is equal to 17 by 18. Okay, so probability of not getting a rupees 5 coin is equal to 17 by 18. And now let us move to next problem. So in next problem, here we have Kofi buys a fish from a shop for his aquarium. The shopkeeper takes out one fish at random from a tank containing 5 male fish and 8 female fish. Okay, see, you can see this figure. So what is the probability that the fish taken out is male fish? Okay, so we need to find the probability that the fish taken out is a male fish. Okay, so let us solve this problem. So here we'll see the answer. Okay, so total number of fishes in a tank, this is actually equal to number of male fishes plus number of female fishes, and this is equal to 5 plus 8, and this is equal to 13. Okay, so probability of getting a male fish, this is equal to number of favorable outcomes divided by number of total possible outcomes. Okay, and here number of favorable outcomes of getting a male fish is equal to 5, and number of total possible outcome is equal to 13. Okay, so probability of getting a male fish, this is equal to 5 by 13. Okay, so now let us see question number 12. So in question number 12, here we have a game of chance consists of spinning an arrow which comes to rest pointing at one of the numbers 1, 2, 3, 4, 5, 6, 7, 8. Okay, you can see this figure in this figure, and these are equally likely outcomes. Then what is the probability that it will point at 8? Okay, number 1 and number 2 and odd number. Number 3 are greater than 2 number. Okay, and number 4 a number less than 9. Okay, so let us find the probability that it will point at these numbers. Okay, so let us see how to solve this problem. So the total number of possible outcomes here in this question is equal to 8. Okay, so probability of getting 8, this is equal to number of favorable outcomes divided by number of total possible outcomes. Okay, and this is equal to 1 by 8. And then total number of odd numbers, one spinner, that is equal to 4. So probability of getting an odd number, this is equal to number of favorable outcomes divided by number of total possible outcomes, and this is equal to 4 by 8, and this is equal to 1 by 2. Okay, and the numbers greater than 2 are 3, 4, 5, 6, 7 and 8. Okay, so therefore the total numbers greater than 2 is equal to 6, and then probability of getting a number greater than 2, this is equal to number of favorable outcomes divided by number of total possible outcomes. Okay, and this is equal to 6 by 8, and this is equal to 3 by 4. Okay, and in next we have to find the number probability of number less than 9. Okay, so the numbers less than 9 are 1, 2, 3, 4, 6, 7, 8. Okay, therefore total number of less than 9 is equal to 8. Probability of getting a number less than 9 is equal to 8 by 8, that is equal to 1. Okay, so now let us move to next problem. So in next problem, here we have a die is thrown once, and we have to find the probability getting a prime number. Okay, and first we need to find probability of getting a prime number, and secondly we need to find probability of getting a number lying between 2 and 6. Okay, so let us find the probability of getting a prime number first of all. So here here the possible outcomes when a dice is thrown is equal to 1, 2, 3, 4, 5, 6. Okay, so number of possible outcomes of a dice is equal to 6. And now let us find probability of getting a prime number. Okay, so prime numbers on a dice are 2, 3, and 5. So total numbers on a dice favorable to the even getting a prime number is equal to 3. So probability of getting a prime number is equal to total number of favorable outcomes divided by number of total outcomes. Okay, so this is equal to 3 by 6 and this is equal to 1 by 2. Okay, so probability of getting a prime number, this is equal to 1 by 2. And now let us find the probability of getting a number lying between 2 and 6. Okay, so number lying between 2 and 6 are 3, 4, and 5. And total numbers lying between 2 and 6 is equal to 3. So probability of getting a number lying between 2 and 6, this is equal to 3 by 6 and this is equal to 1 by 2. Okay, so now let us find probability of getting an odd number. So here odd numbers on a dice is 1, 3, and 5. Okay, so total numbers on a dice favorable to the event getting an odd number is 3. So probability of getting an odd number, this is equal to 3 by 6 and this is equal to 1 by 2. So now let us see question number 14. So in question number 14, here we have on card that is drawn from a well shuffled deck of 52 cards, and we need to find the probability of getting a king of red color and a face card, a red face and a red face card and the jack of hearts, and then a spade, the queen of diamonds. Okay, so we need to find, here we'll find first of all the probability of getting a king of red color. Okay, so total number of cards in a well shuffled deck is 52. Okay, do you all know about this? So first of all, here we'll find probability getting a king of red color. Okay, so total number of kings of red color is 2. Okay, so total number of kings of red color is 2, and then probability of getting a king of red color, this is equal to number of outcomes favorable to the event divided by number of total outcomes. So here this is equal to 2 by 52 and this is equal to 1 by 26. Okay, and then we will find the probability getting a face card. Okay, so total number of face cards is equal to 12. Okay, so probability getting a face card, this is equal to number of outcomes favorable to event divided by number of total outcomes. So this is equal to 12 by 52 and this is equal to 3 by 13. And total number of red face card is 6. Then probability getting a red face card is equal to number of favorable outcomes divided by number of total possible outcomes, that is equal to 6 by 52 and this is equal to 3 by 26. Okay, so probability getting a red face card is equal to 3 by 26. And now let us find probability getting a jack of hearts. Okay, so total number of jack of hearts is equal to 1. So probability getting a jack of hearts is equal to number of total possible outcomes divided by number of total outcomes. This is equal to 1 by 52. Okay, and then we need to find probability getting a spade card. So total number of spade cards is equal to 13. So probability of getting a spade card, this is equal to 13 by 52, that is equal to 1 by 4. Okay, and then we will need to find the probability getting a queen of diamond. So we know total number of queen of diamonds is equal to 1. Okay, so probability getting a queen of diamond, this is equal to number of favorable outcomes divided by number of total possible outcomes, and this is equal to 1 by 52. Okay, so now let us move to next problem. So in next problem, here we have 5 cards, the 10, jack, queen, king, and ace of diamonds. Okay, and as well shuffle with their face downwards. One card is then pick up at random. Okay, so then what is the probability that card is the queen? And then what is the if the queen is drawn and put aside, what is the probability that second card pick up is an S, a queen. Okay, so let us solve this problem. So total number of cards, this is equal to 5, and total number of queens is equal to 1. So probability of getting a queen, this is equal to number of favorable to the event getting a queen divided by number of total possible outcomes. So this is equal to 1 by 5. And then when the queen is drawn and put aside, the total number of remaining cards will be 4. Okay, so total number of S's is 1. So probability of getting an S is equal to 1 by 4. And as queen is already drawn, therefore the number of queens will be 0. Okay, so probability of getting a queen is equal to 0 by 4, that is equal to 0. Okay, so let us see question number 16. So in question number 16, here we have 12 effective pens are accidentally mixed with 132 good ones. It is not possible to just look at a pen and tell whether or not it is defective. One pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. Okay, so here we have total possible outcomes 132. Sorry, total number of pens is equal to 132 plus 12, that is 144. Okay, so total number of pens is equal to 12 plus 132, that is 144, and total number of good pens is equal to 132. Okay, so probability of getting a good pen, that is equal to number of favorable outcomes divided by number of total possible outcomes, and this is equal to 132 divided by 144, and this is equal to 11 by 12. Okay, so probability of getting a good pen is equal to 11 by 12. So student, I stop here this lecture. Thank you very much to all of you.